Hey guys, this is Thursday night's video, and this is just some practice problems for the quiz tomorrow, okay? If you are just gonna sit and watch, I'd say you might as well just turn it off and go turn on YouTube, because that's not the point of this video. There's a set of practice problems. It's basically a practice quiz. You wanna pause now, work through each of those, turn it back on to have me solve them and explain them real quick, and then figure out anything you're missing so you get an A tomorrow. Okay? Pause it now, get to work, start with that problem at the bottom of the page. Which problems require a common denominator? Go. Did you pause it yet? Hurry up. Okay, let's go. Starting at the bottom. Which problems require a common denominator? Anytime we add or subtract, we have to have a common size piece, okay? That means number 1 and number 3 require common denominators, okay? 2 and 4, multiplying and dividing, can be done with any types of fractions with each other. There's no requirement. We're not working with same size pieces that need to match up. Let's dive in. Number 1, I need a new common denominator. I'm hoping you guys saw that 14 is a multiple of 7. That often happens with fractions. I use that on purpose to try and get you guys into that habit. You can multiply 7 times 14, but if so, you're working with, I think, 98 right now. And that's going to be a large denominator and a lot of reducing. All right, this left side, I doubled the 7 times 2, so I'll double the top times it by 2. This, I didn't do anything, so I leave it as is. Important thing to watch for right here, guys. -6, and then a subtraction, which in a minute we should see we can rewrite as adding -5. So we got -6, -5, -11, and they're all 14ths. All right, number 2. First off, I'm going to notice there's a pair of negatives. I'm just going to cancel those guys out. And now I'm going to get to work. You could go straight across. But if you notice, those are pretty big values. So I'm hoping you're getting pushed toward this new concept of reducing before you multiply. All right? I'm going to look at that 8 and 12. What can I take out? I can divide a 4 out of the 8. Makes it a 2. A 4 out of the 12, and makes it 3. Over here with 10 and 15. I can divide a 5 out of the 10 to make 2, a 5 out of the 15 to make 3, and then final answer, 2 and 3, 6, 2 and 3, 6. Final answer, 1. Okay, continuing on. Number 3, we need to get common denominators again. Let's get that out of the way. 6 and 8, I could multiply to get 48, but if I don't have to go that big, I don't want to. So I'm thinking 8, 16, 24. You know what? I think 24 is a multiple of 6. And it is, so I'm going to use 24. Don't forget the negative. 8 times 3 made 24, so I'll multiply the top by 3 as well. 6 times 4 made 24. I'll multiply the top by 4. And we're on our way. Now, did I catch anybody with this negative and confuse you? I put it down there on purpose to see if you were awake. Remember, it doesn't matter. The negative can go anywhere, so I'm actually going to move it up to the 16. It's anywhere on the fraction. It's all equivalent. And now it makes a lot more sense because what I'm really doing is adding 9 plus -16. That 24 on the bottom is just going to stay 24. So it's really just good guy, bad guy integers. I've got more bad guys. I'm going to subtract them. 7. Since there were more bad guys, -7. All right. Last one. I'm going to see 2 negatives. I'm just going to cancel them right off the bat. And I'm going to rewrite this guy because I actually need multiplication, not division. So I flip the second fraction. And here I am. And now I'm going to look for any reducing I can do now, because those are much bigger numbers than I want to have to work with. So let's reduce away. 11 and 33. I'm going to take a group of 11 out of 11, so I'm dividing it by itself. Divide 11 into 33. Wow, that's so much easier. Next, I'll divide out of the 8 and 10 a common 2. So 8 divided by 2, that leaves 4. 10 divided by 2 leaves 5. That stupid question is still in my way. I should have erased the whole thing 10 minutes ago. Hello. 1 times 5 is left over on top here. It gets so much simpler after I reduce. 4 times 3 on bottom. Boom. Wow, simple. All right, that's pretty much the quiz. I would have 2 points each that those were worth, so that would be worth 8 points on the quiz. You can grade yourself right now. If you made one small mistake along the way, that's 1 point. If there were kind of multiple mistakes and you kind of broke down along the way and didn't really get close, that'd be both points. You can see how you did. All right, let's look at proportions. And notice, you can use a calculator for these problems because it's going to be a pain otherwise. All right. Now, notice I said show if they're equal. That's going to be on the quiz as well. If you just do like this and move on, I'm just going to mark it wrong. I want to see, because otherwise it's a 50-50 chance. You could have no idea and just guess, and you have a 50-50 chance of getting the answer. I want to see some math. I want to know you know it. So what I need to do is have you show me. So the easiest way to do this is doing our cross multiplying. If these are equal, then this is going to be the case. Then that means those pairs are also going to be equal. I've got my calculator in hand. By the way, you should have paused the video to do these. I forgot to say that. These should be yours to be doing on your own. If you haven't yet, stop, pause me, do the rest of the page, then come back and check. Okay, are these guys equal? No, they are not. Now you could say no, because I see how you got to that. That's full credit. Okay. Number 2, we're going to do the exact same thing. And with a calculator, this should be pretty darn quick and easy. There you go. Yes, they are. There's the work. There's the credit. All right. Last 3 and 4. Find X. There it is. Done. All right. See you guys tomorrow. I'm joking. If you do that on the quiz, I'm going to mark it wrong. Don't even think about it. Okay. So, you've got multiple choices here. I showed you 3 ways in the video. Take your pick. I'm going to look for the simple ratios first. I'm going to check there. And yep, 4 does become 24. That's a direct multiple, and it's times 6. So that makes my life easy. That means that this way is also times 6. 6 times 8, 48. Okay? Now, that's not the only way you can do it. You want to know the different ways, because different problems will have different numbers that work. You can also go top to bottom here. I also see that 4 times 2 is 8, which means I can also do it on that side, and 24 times 2, 48. So either of those works. And if you would like, you can also use the cross multiply that we just did on the other two problems if you want to go that route. 24 times the 8 equals the 4x. And then figure that out and divide by 4 to see what x equals. That would also give you 48. All right, last one. I'm looking and there's nothing here. 20 to 30 is not an easy multiple. It's not a whole number. I'm looking here, 16 to 20. Top to bottom is also not a multiple I can use. It's not a whole number. So that means I'm gonna have to go with this cross multiply. I'm gonna use my calculator. That tells me that final answer is probably, no, it might be a whole number, but it's not, the multiples are not whole numbers. So a calculator might be helpful. 16 times 30. It's going to equal 20 times x, which we can just write 20x. Okay, I can actually do this one in my head. 6 times 3 is 18, or excuse me, 16 times 3 is 48, excuse me. And then there was a single zero, so I'll add that on, 480. Okay. I want to know what x is, so I've got to divide off the 20. If we cancel the zeros, the 2 goes into 48 24 times, which means x is 24. All right, there you go. So there's multiple different ways you can work with ratios and proportions. Last thing, bonus problem. There'll be a bonus problem on the test, and if you want to understand this stuff and get the extra point, you should do that. We did a little bit of this in class. If I've got 3 1/2, negative 3 1/2, in order to do any operations with fractions that are mixed numbers, you've got to put it all back into one fraction. So 3 times 2 is 6. Okay, I'm going to multiply here. Then I'm going to add that up to the top. 6 plus 1 is 7 halves. And the whole fraction is negative. Don't think of it as a negative 3. Think of it as a negative 3 1/2. The whole thing is a negative number. When I rewrite it, it's still a negative number. Do the same thing here. 5 times 3 is 15, plus 1 is 16 thirds. And now it's just a multiply problem like you've already done. I'm going to look for anything I can reduce out. Take out a 2. I'm going to divide a 2 out of both of those numbers. Now I've got 7 times 8 is 56. Don't forget your negative. 1 times 3 is 3. And there we go. Pretty simple. Second problem, same exact thing with the division. 6 times 3 is 18 plus the 1. I have a total of 19 thirds. 3 times 5 is 15 plus 3 is 18 fifths. Don't forget your negative. And now I've got to take it on as a division problem, so I'm going to flip it. And I'm hoping there's some reducing I can do here. Oh, I did it wrong. I tried to get it ready to reduce in my head, but it was a division problem, so I did not line that up. Well, that's life. So if you guys get stuck with something like this, it's still just straight across. And notice, nothing on top will reduce with anything on bottom, which means we don't have to worry about reducing when we're done, but we are going to multiply and get big values. 19 times 5, that's going to be 95. 3 times 18, what is that, 54, I think. And there was nothing to reduce before, so there won't be now, and there you go. All right, last thing, for anybody that's unsure about how I turned 3 1/2 into the improper fraction, watch this. If you know that, you're free to go. Okay, so what we've got going on here. So we've got 3 whole candy bars. And then we've got a half candy bar. So that's what we're dealing with. As far as the negative, ignore that. It has nothing to do with this rewriting process. We'll just make the answer negative when we're done. Okay? So if I have 3 1/2 candy bars right now, and I want to turn that into all halves, all I'm really doing is chopping all of these candy bars in half as well. It's the same amount. We're just now seeing them as individual halves. There's 2. There's 2 more to make 4. There's 2 more to make 6. And there's 1 more to make 7 pieces of size half. So to understand how we get this part of it without having to draw it all out, we're just multiplying. 3 times 2 is 6. That step right there shows us all the whole candy bars turned into halves. So that's 6 pieces of size half. 3 times 2 is 6. And we keep going, and we add the half that we already had to begin with. Okay, so there's that extra half. 7 halves. And that's how that came out. So 3 times 2. The 3 times the 2 makes 6. Add on the 1 to make the 7, and then rewrite it as 7 halves. There you go. All right, guys, good luck. Ask me questions if you have them. Well, no, the quiz is Friday. Ask questions hopefully earlier today with me if you had them. See ya.